Hi students, today we are going to be talking about experiments. So first, I want you all to try something for me. In class, I gave you all some paper, so I want you to grab some of the paper, and I want you to make a paper airplane. So right now, seriously, I want you to pause this video, I want you to make a paper airplane and see how well it flies. All right, so now you've flown your paper airplane. Now I want you to make some changes to it. Maybe you'll change how it's folded. Maybe you'll add some things. You could even do cuts. You could throw it a different way. Anything. You be creative, but as you are doing this, I want you to pay attention to what you try and what the plane does, and I want you to try at least 3 different things. So again, pause the video, and I want you to go make some changes and see what happens. So at this point, you have made your paper airplane, you've made some changes. So maybe you changed things like the wing shape. Maybe you added some extra folds. Maybe you cut a notch in it. Maybe you folded in the nose piece. Maybe you threw it a different way. Maybe you threw it harder, or maybe you even used a different piece of paper. You didn't have to just use my paper. There's lots of things you could have done for your paper airplane, and maybe your plane flew farther, or did loop-de-loops, or flew off to one side, or crashed at your feet. I'm not quite sure what happened, but you did both of those things. So why are we doing that? Because today you all are learning about experiments, and you all just carried out an experiment with the 2 most important parts of an experiment, the independent variable and the dependent variable. So your independent variable can be abbreviated the IV, and that can help you remember it's the I variable. So all of those things that you did to your planes, those are all things that I could do to my paper to make my planes. So that is the independent variable. So all the things the plane did, that's the dependent variable, whether it flew farther or shorter, whether it veered off to the side, whatever happened, that's how the plane reacted. So those are the dependent variables, and we often abbreviate those the DVs. So this was a very basic experiment. We are now going to start doing some more about experiments. If you look in your book, if you have your book, today's activities are actually filling in some of your notes on page 16 and 17 in your book, so if you want to get that out. And now let's talk a little bit more about experiments. And we're going to look at things where perception is not always reality. So let's look at some examples of what I'm talking about. So how many legs does this elephant have? Maybe you see 5 feet, 4 legs. You know elephants are only supposed to have 4 legs. How about this one? Are the horizontal lines parallel, or do they slope? They're actually parallel, but it looks like they slope because of their pattern. How about this picture? Is it moving, or is it not? Try focusing in on one particular place on this picture, and it'll stop moving because the picture itself isn't actually moving. How about this picture? This is a top hat. How does the height of this top hat, the distance from A to B, compare with the width of its brim, C to D? You know what? They're actually the same. How about this letter T? Similar kind of question. Is the letter T's crosspiece, the part that's horizontal, a different length or the same length than its stem, the vertical piece? Maybe you're not surprised at this point with the other optical illusions that I've shown you, but the horizontal piece is actually the same length as the vertical piece. That cross piece and the stem are the same. So why? Let's start asking some of these questions. Let's look at the T illusion picture just because it's the simplest. And I even can write a letter T. Why is it an illusion? Why does it look like they are different lengths? What features about it is responsible for the illusion? So we could come up with lots of ideas about what causes this T illusion to look like an illusion. Maybe you're thinking that it's because it's up and down this way, that orientation of the T. Maybe it's the color of the T. Maybe it's the color of the paper, this black versus white. Maybe if the T was different colors, like maybe if the cross piece was one color and the stem was a different color, maybe that would make a difference. Maybe it's the size of the T. Maybe if it was tiny, we'd be able to beat the illusion more, or if it was big, maybe that has something to do with it. Maybe it's the angle of the cross piece of the T. Maybe it's because it's this perpendicular shape. What if it was at an angle? Maybe we wouldn't have the illusion quite so much. Maybe it's the thickness of the lines making the T. Maybe it's if the cross piece and the stem are touching. What if they were separated? Would we be able to figure out if they were the same or different lengths easier? What if it's about that T being centered on the paper or not? What if it was over in the corner? So all of these things could be what causes the illusion. And you might have even thought of even more things that cause that T to be an illusion. So let's test them. This is science. We can do experiments to figure out, do any of these matter? Do they make a difference? But first, we need to remember what makes a good experiment. So for your parts of an experiment that you need to know, we've already talked about two of them. We've got the independent variable. The independent variable is what I can change. The dependent variable is how the thing changes, what we're measuring, what we're looking for in an experiment. Some other parts of an experiment, we've got constants. Constants are things that stay the same the whole time. So if we're thinking back to our paper airplane experiment, if you really wanted to figure out, does wing shape make a difference? Then for constants, you should throw it the same way every time. It should be made out of the same paper every time. The wind currents in the room that you're in should be the same every time. So all of those things should stay the same so you get a fair comparison. The trials is the number of times you do an experiment. So did you just throw the paper airplane one time with each type of fold? Then you would have had one trial. If you tried each variety of your paper airplane, if you tried it multiple times, then you would have done multiple trials. Maybe you threw it each way 3 times and then changed a fold and then threw it 3 times. So the number of times you do an entire experiment is the number of trials. And then you've got a control, which is a non-treatment group that you're going to use for comparison. Paper airplanes don't have necessarily an obvious control unless you have just a standard, like typical airplane design maybe, and maybe you want to see, does a notch make a difference or not? So then maybe you would have non-notched wings as the control and notched ones as the other one that you're going to use for comparison. A different example to give you an idea for a control, maybe if you're thinking about growing plants, which we will be growing plants this semester, but maybe we're going to grow plants with different amounts of salt. So a control would be the one we don't give salt to, because we need to see how plants grow without salt. So that would be our non-treatment group. All right, so we are going to test this T illusion. And first, we're going to talk about an experiment that we can all do together. So I'm just picking that very first one as our example here as a class, that orientation of the T. Does it make a difference if the T is upright or to the side or upside down or the other way? So that's what I mean by orientation. So the independent variable is going to be the direction the T is facing. That's what I can change. The dependent variable is going to be the length of the stem that we think is the same length as the crosspiece. So maybe you've taken a look at your T page that I also gave you when we saw each other in class. And we're going to set this experiment up that we're going to have to decide quickly where the length of the stem is going to be equal. So that's what we're going to measure. You'll see. I'll show you in a full screen in just a minute. So some things that are going to be constant. We're going to leave the color of the T and the paper, the thickness of the T, all of those other ideas that we had, we're going to leave all of those the same. You're just going to use the T that I gave you in class. It's going to be touching, it's going to be at this perpendicular angle. All of those are going to be constants for the entire experiment. Some other things that should stay constant is the lighting in your room wherever you are doing this. So you shouldn't turn off the light in the middle of the experiment or change the lighting. Also, we want to leave the amount of time to decide the same. So let's do it as fast as you can. Aim for under 5 seconds to make your decision each time. Now, since you're going to be doing this on your own, and we're not going to be able to pool all of our data together as an entire class like we would if we were all actually together, you're just going to have one set of numbers, unless you were to decide to do this multiple times. But I'm not asking you to do that in this video. So you're going to do this experiment one time. So it's going to face this way, and this way, and this way, and this way. All of that, you're just going to have done the entire experiment once. Our control is going to be the original direction of the T. We know that works as an optical illusion. That was our original, so that is going to be our control. So you are now going to do this experiment, but before we actually take our data, the last thing we need to do is we need to have a hypothesis. And a hypothesis is going to be our statement that is a testable statement about what we think is going to happen. So a hypothesis, you could pick lots of different hypotheses. The hypothesis that I made is I think if the T is on the side, and I would be more accurate to figure out where is the right distance. So I think if the T is on the side, we're going to be more accurate than if the T is facing up. So I think it's something to do about this up and down. And if the T is on the side, that we're going to be able to beat the illusion better. But I don't know. That's why we're going to do the experiment. So let's try. All right, so let's try our experiment with our T illusion. So in the papers that I gave you in class, you should have a paper that has a T on it. Now looking at this T, it is hopefully obvious to you that the cross piece of the T, here I'm measuring it as 10 centimeters, is definitely a different length than this stem piece, which is 15 centimeters. So obviously, this isn't for an illusion right now, but this is for our experiment. So this stem piece is much longer, and our experiment is going to be, you're going to take one of the other pieces of paper that I gave you, and you're going to cover it up and decide where is it that it is equal. So you're going to cover up your T so that the stem piece is the same length as that cross piece. Now, could you do what I just did and measure with your fingers? No, that is cheating. Should you go ahead and measure it with your ruler? No, that is cheating. What you're going to do is you're just going to look at it and you're going to have to decide, and we should do it as fast as possible. If we were being really accurate, we would even give ourselves a time limit, maybe like a 5-second time limit to look at it and pick, because otherwise you're going to sit there and try to figure it out. So if you have a way to do like a 5-second time, do a 5-second time limit. But what you're going to do is you will cover it up and say that is where I think it is. Then, if you have a ruler, actually take your ruler and measure. And you can see, oh, I was at 10.4, which is not bad, considering this was 10 centimeters. Now, if you don't have a ruler, you can take one of your other pieces of paper and you can mark the distance on one of your other pieces of paper. So this was when it was facing like this. Do not mark on your letter T, because otherwise that's going to give you a hint of what you thought before. Okay, so you're going to do that, and then you're going to turn your letter T. And you're going to take your piece of paper, and you are going to try again and measure. And then you're going to turn it again. And same thing, and turn it again and measure. So take a minute and you try it with your letter T and your paper. All right, so now that we have done the experiment about the orientation of the T, now I want you to design an experiment to test a different idea about what causes the T illusion. You only have to design it. You don't have to actually carry it out unless you want to. But what I want you to do is, here are all of our ideas about what causes that T illusion. We've already tested the orientation. So now I want you to pick one of these other ones or something that you have thought of, and I want you to decide how would you test it. Just like we did with the orientation of the T, decide what would your independent variable be? What would your dependent variable be? The constants, the control, all of those things. So what would that experimental design be? All right, so now you've designed your experiment. Why did we do this lesson? So, main reason is to see how science works. Science is based on doing experiments. So we've got to learn how experiments work. Also, why did I pick illusions, optical illusions? Because I wanted you all to remember that we are surrounded by natural illusions. What do I mean by that? The Earth seems flat. We talked about that last time. The sun moves across the sky and we stay still. That's what it looks like. Looks like species stay the same generation after generation. It looks like the speed of light is instantaneous. It looks like the continents are fixed. It looks like rainbows are things we can actually touch or chase or find the end of. So what does science do for us? Remember, science is all about looking for explanations. So some of our scientific explanations of our natural illusions is that instead the Earth is round. And it's the Earth that revolves around the sun instead of vice versa. Species do change. Light has a speed that we can measure. Continents move, and rainbows are just bent light. So science is out to explain the natural world instead of us being tricked by illusions of just what we think we see. Science is out to explore and explain. And we do that through experiments.